On this Ram 1500 with the 5.7 gas engine, P0522 means the PCM is seeing the engine oil pressure sensor signal lower than expected. The driver may see the MIL on, and depending on what the PCM is seeing, the concern can point toward the oil pressure sensor circuit, the sensor connection, the 5-volt supply, the signal wire, the sensor ground side, the sensor itself, or in the end, the PCM. Treat this as an electrical circuit diagnosis first, and start with the basic system checks before going into pinpoint testing. The PCM supplies the engine oil pressure sensor with a 5-volt supply. The sensor signal circuit can be pulled up at 5.0 volts or pulled down at 0.0 volts depending on the PCM hardware. For this code, the monitor runs with the ignition on and battery voltage above 10.4 volts. P0522 sets when the EOP sensor signal voltage at the PCM is below 0.290.1 volt, depending on calibration, for approximately 1 second. Use that information as the monitor gate and the diagnostic formula, not as a reason to jump straight to a sensor. First, read codes in all modules and save the scan report and recorded data. Clear the codes, turn the ignition off for a minimum of 10.0 seconds, then turn the ignition back on. Reproduce the operating conditions that set the code using the captured data, then read codes again. If P0522 does not return, handle it as an intermittent condition. If it does return, keep going. Before testing the oil pressure sensor circuit directly, look at the recorded codes. If any 5-volt reference codes are present, diagnose those first. A shared reference problem can make this code misleading. If there are no 5-volt reference codes, move to the oil pressure sensor connector. Turn the ignition off. Check that the EOP sensor connector is fully seated and locked before disconnecting it. Then disconnect it and inspect for pushed out, damaged, or spread terminals. If you find a connector or terminal issue, repair the terminal or reconnect and lock the EOP sensor connector properly, then retest and verify the repair. If the connector and terminals look good, continue with circuit testing. With the EOP sensor connector disconnected, measure voltage on the F855 5-volt supply circuit at the sensor connector. The expected range is between 4.9 and 5.1 volts. If the voltage is in that range, go on to the signal circuit checks. If it is not, repair the F855 5-volt supply circuit for an open or short to ground, then verify the repair. Next, isolate the EOP sensor G6 pressure signal circuit and check it for a short to ground. The ignition must be off for continuity to ground testing. Disconnect the ECU and every component connector that contains the circuit being tested, and use the wiring path to follow the circuit. Connect the DVOM negative lead to a known good ground, then probe the signal circuit at the component connector with the positive lead. If you have to work at a PCM connector, use the GPEC diagnostic adapter 10436. Do not probe the PCM harness connectors directly, because that can damage terminals and create poor pin contact. If there is continuity between ground and the signal circuit, repair the short to ground and verify the repair. If there is no continuity, move to the next short check. Now check whether the EOP sensor G6 pressure signal circuit is shorted to the K900 sensor ground circuit. Keep the ignition off. Isolate the circuits by disconnecting the ECU and every related component connector. Then check continuity between the two circuits at the component connector. Use the GPEC diagnostic adapter 10436 if a PCM terminal location is involved, and do not probe the PCM harness connector directly. If there is continuity between those circuits, repair the short between them and verify the repair. If there is no continuity, continue to the open or high resistance check. With the ignition off, isolate the EOP sensor G6 pressure signal circuit by disconnecting the ECU and the component connector that contains the circuit. Before measuring circuit resistance, check the resistance of the DVOM leads so you know what the leads are adding. The GPEC diagnostic adapter can add up to 1 5 ohms of resistance to the circuit. Measure the signal circuit from the component connector to the GPEC adapter. If resistance is below 3.0 ohms, continue to the sensor simulation step. If it is not below 3.0 ohms, repair the signal circuit for an open or high resistance and verify the repair. At this point, the ECU connectors need to be connected for the next test. Leave the sensor connector disconnected. With the ignition off, connect a fuse jumper between the EOP sensor pressure signal circuit and the 5-volt supply circuit at the EOP sensor connector. Turn the ignition on and read codes with the scan tool. If the scan tool shows the sensor signal circuit high code with the jumper in place, the PCM can see the signal change. So replace the faulty sensor and verify the repair. If it does not show the high signal code, continue to the PCM and connection checks. If the circuit and sensor simulation checks did not prove the fault, handle any applicable bulletins, then inspect the PCM and related connections. Disconnect the PCM connectors, related inline connectors if equipped, and related component connectors. Look for connector installation problems, damaged locks, corrosion, signs of water intrusion, weather seal damage if equipped, bent terminals, overheated terminals from poor contact, push-back terminals, spread terminals, and poor terminal tension. Repair anything you find. Then reconnect the PCM, inline, and component connectors, making sure every connector is fully seated and locked. Clear the codes, operate or test drive the vehicle under the monitor conditions, and read codes again. If P0522 returns after all of that, replace and program the PCM, then verify the repair. If it does not return, the wiring or poor connection problem has been repaired. The clean path on P0522 is to prove the code returns, rule out shared 5-volt reference problems, inspect the sensor connector, test the 5-volt supply, check the signal circuit for shorts and resistance, then use the fuse jumper test to confirm whether the PCM can recognize a high signal. Keep verification separate at the end, clear it, run it under the right conditions, and confirm the code stays gone. For more diagnostic training, visit stepdiagnostics.com.